This is somehow logical continuation of my presentation in last iCC. And outline is this. First, we take a look at the typical things happening in the machinery production and operation and maintenance in the field. And then we end up by taking a look at the potential outcome of this transition. And then introduction of advantages of following first standardized CANopen design process and also adopting the proven CANopen principles in the assembly and service. The new approach actually implements external process for supporting the spare part configuration and field measurements. But quite typical currently in the field service is that still different kind of information need to be written manually by the service technicians. Such information includes part numbers, ID codes, spare part orders, different kind of reports and failure indications. And then, especially while troubleshooting, almost the entire documentation is in the traditional format where the technicians shall manually search the required information, including part numbers, contact information for ordering spare parts. And what's worse is that also the parameter values, if such are adjusted. And then, if there's no fixed parts for each position, and if there's two options, either there's fixed PLC application expecting certain device type, and we can just imagine when the devices are coming and going from the market, then in the worst case, the PLC application shall be updated first. Of course, if you have safety system, it's not enough to recompile the application, it shall be reapproved also. That's why it is interesting to achieve situation where we just need to change the part itself, not the control application. And of course, I know that many machinery companies currently, they are configuring sensors and actuators manually, just by sending SDOs without any systematics. And then spare part orders. Typically, especially the bigger companies, they have a couple of order desks around the world, and then it's up to the service technician to detect where to call. And also, typical way of working is still to publish spare part codes in a PDF or even hard copy. And still the case may be in the field that there may be this and that parts replaced by, let's say, innovative service technicians. And in the good case, the existing parts may be valid one, but so old that it's not available anymore. And then logistics, typically logistic process is more or less sending packets by logistic companies, but not following up the real machine structure in the field, so that the machine vendor knows exactly which component codes and serial numbers apply for each position. This leads also into problems when still valid parts which may be unstable but mostly working, they may be recycled back to the operational use, introducing serious risks. And then in the assembly, typically there is still no support for second sourcing. And even as I already introduced, there may be all too often a need to update the control applications just in order to change the small pressure transmitter. And then the same problem applies in both assembly lines and field service. And what happens typically? Time after time, all those service technicians perform certain activities. And step by step, the safety performance will be degraded over the time, small piece by small piece. And in theory, the first stage, which has been originally delivered to the market, that may comply with the certification. But typically certification is made for the design only. And then implementation and each service action introduces some degradation, which may end up with significant safety problems. What is provided by CANopen is the standardized design process. Profile databases are a nice way to bring in application-specific interface descriptions. And from them, it's easy to combine EDS file defining device-specific interfaces. And then in the system design, EDS files are used as a template for creating target position-specific DCF files containing entire configuration. Then it's possible to introduce, let's say, optional devices or second sources following the same principle. And as a final result, DCF files, because they contain full configuration information, it's a natural format for communication of configuration data from design office to the assembly line and field service. And then majority of the system tools, they are able to generate DBC file, which is de facto description for analyzers. So from design process point of view, there's excellent support for assembly line and field service. The only thing we need to do is to arrange same kind of systematics to the assembly factories and field. And the way to go. As I presented in last conference, the first thing to do is to get rid of the manual reading and typing, which may be done by replacing or supplementing all those small plates in the system by machine understandability, which may be QR code or NFC tag or a combination of those, so that part numbers, target system and position IDs and user IDs can be read automatically without manual typing, relieving of human mistakes. And then many things, after bringing that machine understandability, many things may be performed in the background. Just like order deliveries, it's quite easy to read only installation location and click button or order spare part. And then certain magic may happen in the background. Also searching of various things, just like documents, drawings, let's say service procedures, may be searched by computers in the server side, not by the technician itself. And then with the clever support for interlinking of certain information and also linking of documentation and application will speed up significantly the service operations. And what's best, when we have cloud-based system, we can, in the background, we can accumulate each transaction we are doing without any intentional reporting, which will actually relieve significant human effort from the service technicians to the real problem solving and real tasks instead of just writing reports. Same applies for reporting exceptions. No more thinking which kind of exception the technician really met and where to report. System can, in the background, communicate such information forwards. And then, of course, systematic parameter management. When this process is external to the control applications, then we can get rid of the, let's say, overhead, recompilation, reapprovals, and so on. Application will change only when we need changes in the application behavior. And the configuration management has a different approach. And as I already presented, there's quite good starting point for integrated workflow from the system design, utilizing the CANopen process. And also the exception management may be integrated when we can rely on the machine understandable identifiers. And then spare parts may be ordered quite easily because we may implement direct integration. The right order desk may be found actually in the background, while the physical location of the service technician is known. It's more recommended to use target assembly location rather than just an ID code, because then we are totally independent of the component existing in the system. It may be pirate part, it may be obsolete part, and still the technician can order just the right part. And what's best, again, important information will be accumulated also in the background. And in the logistics side, when we follow also internally the material flows, we may follow which part individual part has been installed or removed and to or from which system. So the system's technical file can be maintained always up to date. And that will also enable easy identification of discarded parts. And in that way, it's possible to prevent recycling discarded parts back to the business, causing safety risks. And then in the assembly line, there will be systematic support for second sources, upgraded devices. And what's best, the part change will require only change of the part itself, not mandatory application upgrades. Which means that in the field, after, let's say, sensor break, the machine operator don't need to wait for 2 months for a next software release, having support for the new part and configuration for it. Together with let's say, aggressive utilization of device profile, this will be very efficient. And again, everything what happens in the field the information will be accumulated in the database and it's immediately available for various automatic reporting. Just one example, order email, where we have interesting information here. There's target system and target position information for the all too typical cases that the system supplier don't have valid spare part definition available. This applies even especially to the older machine models. And then there's primary item and also second sources. So the technician don't need to do anything else than click in the user interface, order spare part for the given position, and the order desk gets this kind of information. And if the technician is interested in, let's say, he or she reads a cable identifier tag, he or she can click button, show in drawing, and then the server looks for the correct cable item, shows correct schematic with that required cable highlighted. I have quite a lot of experience on field service and supporting the service technician, and I have been all too often in the field looking several big bunches of schematics just to notice that yes, just the required sheet has been removed, but not really. But here the information is always available, and it's only up to the design department how up to date the information is. And then when we go to the configuration download, the most typical case is that the device available is not a valid one, or the configuration packet for that device may not be consistent or whatever. There may be some, let's say, missing license for the download tool, whatever. Or the technician does not have a clear idea what to do, as in this example. This is notification email triggered by aborted download. After aborting download, the technician don't need to think about where to call or where to send email, what to describe, what to attach, because there is already clear indication at which position the problem has occurred, timestamps and so on, and there's also URL to the corresponding history here. And it leads to the let's say action history, where we can, or the corresponding support engineer can take a look at where the tag has been read, where the operation has been selected, where the download procedure has been started, and when it has been aborted or when the failure has been occurred. So there's automatic reporting behind, so that the system vendor can react immediately on the problem. And especially, this is a guarantee that information goes back to the factory before 1 year has been elapsed, which is a typical case that when the service technicians are coming to the next education, they are shouting to the design engineers that you bloody idiot, what you have done again. But this gives, let's say, official formal information, providing clear indication of what has been happened and where and when. Of course, same applies for troubleshooting measurements. If you are analyzing your network and there may be missing license in the analyzer, or there may be invalid packet having let's say not so correct DBC files or invalid bitrate or whatever. Within few seconds after meeting the problem is officially recorded. And then, if there's failure indications which can be made by both humans and by control systems, they are also recorded, and there's background post-processor looking for repetitive failures. And again, after each repetition, this kind of notification email will be sent with certain information included and also URL to the corresponding report, which may provide further information, further links, serving troubleshooting of these scenarios. And then, because everything will be recorded, it is possible to build this, for instance, this kind of reports for analyzing, visualizing how the problems are spatially and categorically distributed, so that we don't repair the wrong locations. So, to be summarized, while using this kind of concept as an extension of CANopen design process, it's possible to guarantee that correct spare parts are ordered always independent what exists in the system. And users don't need to search anything. Thanks to the strong context sensitivity of the identification systems, and then thanks to the automatic searching of documentation and packets, and also heavily linked information. As long as the design information is consistent, different disciplines, just like CANopen system description, electric schematics, hydraulic schematics, mechanical models, may be linked together. And then the background status accumulation and alarm functionality, so that without any intentional effort by the service technician, help may be obtained already, which also helps in avoiding human mistakes. And in addition, reports may be linked to those, so that the one who is reading those notifications gets always up-to-date information. And that's the final point, that with this kind of arrangement, the system suppliers can really keep up-to-date about the real field status. They don't need to figure out whether there's everything okay because nobody is calling. Now everything can be recorded, reported, analyzed in the systematic way. And the last point is the most important. We can avoid repairing the healthy positions of the system. If we repair the healthy positions, they will be broken at some time, causing further problems and further cost in the real life. Yes, thank you.
Thank you. Thank you. Are there any questions from the audience here?
I'm leaving Germany tomorrow afternoon, so I don't have hurry. Please ask.
Okay. Yeah, I think so. So we can close the last session of the CAN conference. Thank you again.
Thank you.
I would